Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, everyone. Welcome back to another exciting edition of IT Pro TV. I'm your host, Vaughn Smith, and this is our Cisco Cloud Fundamentals exam series. And in this episode, we're talking about virtual networking services in our cloud networking topic. And back in studio to help us is Mr. Ronnie Wong. How are you?
I am doing well, Vaughn. Thank you again for joining me as we continue on in our Cisco Cloud Fundamentals series here. We are taking a look, of course, like Vaughn said, at the issues of cloud networking and some of the different topics that we need to cover. And Vaughn, this is where most of us that have a traditional networking background, when we start talking about the idea of cloud networking, this is where the disconnect really begins to happen. One, if you're a Cisco guy like I am and you've actually been working with the equipment for a while, you tend to really appreciate the very fact that you have a hardware component that you can go to and you know that that device is doing what you need to, or it fails and it's doing what you need to. But once we start heading into the cloud environment, understanding like, well, I can't any longer say that this piece of equipment is malfunctioning, and I can't even reconfigure somebody else's equipment because I may just be a customer or a tenant of a cloud provider. So now, what do I actually do? Well, there's a lot of different services that are out there that help to provide what we call networking services for us. And these services, of course, are going to be available to all the tenants that you are actually going to be supporting one day, or maybe even to yourself if you're managing or administrating a cloud tenant in a Cisco space, where you have to understand some of the networking services that are available to you, but also understand a little bit about how they work from the Cisco perspective. So Vaughn, in this particular series, we're really going to be taking a look at that idea of what we call the idea here of virtual networking services, and what does it do for us, and what we need to know about it as we get ready for this exam too. Okay, so Vaughn, sound like a lot of fun talking about networking, virtual networking here?
I'm super excited.
Yeah, it's probably not the easiest topic because unlike the regular Cisco shows that we do, Vaughn, there's times I can literally bring out a switch and show somebody, here's the port you would plug into, and I can turn it on, and you can see lights blinking, and you can see that, and I can actually show you, I plug a console cable in, and I can configure it and make it work. But Vaughn, once we start saying that we're going to run this stuff in the cloud, all that stuff disappears. And now all of a sudden it's like, what am I configuring? What is it really, doing in the background? What is happening here? And that's what we need to talk about as well.
But one thing that I've really enjoyed throughout this series so far, Ronnie, is your diagrams. All of the different things that you draw. I mean, you were actually showing us like the different components and how it relates. So I've been following along just fine. And like, oh, yeah, okay, I get it. I connect what this was in real life to what this is in the cloud. And so you're connecting the dots for me, Ronnie. So
Yeah.
do we have more diagrams today?
We'll take a look at some of the different diagrams. And the reason why diagrams are important is because for us, right, we no longer have those pieces of equipment that's going to be something where I can tell you this logically connects to this and, or actually physically connects that. Whereas in Cisco equipment, I can bring, Vaughn, a switch and a router and connect those two together and show you how that connects together. I can then take a cable and plug it in a computer, and you can actually physically go in there and see this is what connects to what. But in the cloud, though, Vaughn, I'm actually telling you that these things exist and that they work, okay? And Vaughn, once I say that, people are saying, well, how do you know that they're working, or how do you actually make sure that that's working? Well, you can't. You can't walk in somebody's data center and simply go, show me this switch that's actually for my network right here. I want to see the physical component. It's not there.
Yeah, that tangible, like I can actually touch this or I can see it with my eyeballs, like right in front of my face. It's one of those, well, you just have to trust that it's there. This kind of ethereal thinking
Right.
of like, it just exists. Well, what do you mean it exists?
Yeah, it's hard to know, but somewhere in the background, there is some hardware that's out there. But remember that once we start moving in the cloud, the emphasis is no longer on the physical hardware itself. It's now on, of course, the virtualized types of hardware. And for us, the idea of virtualized services. Now, I've been using that term. That's the third time I've used it in this series, in this little episode so far. But when I start talking about virtual networking services, these are some of the same services that you and I would use on just a regular physical network. Okay, so let me give you an example. A router. Okay, that actually provides for us a service from my network that allows me to connect outside of my network to another network, whether it's to another subnet, maybe to another department that's actually in a different IP address range, or it can connect me out to the internet, or it can connect me to a business partner. You name it, I can actually go into our particular server room that we have here and actually show Vaughn where the router is and where it connects all the way out to our ISP provider and actually say, here's the device that makes that connection happen. So, Vaughn, I could do that, but in the cloud, I can't. I just have to say, Vaughn, here's the router, and we're simply going to configure it. Well, how do I test that out and verify it's working? Well, you just kind of do some of the things you would normally do on a regular router, and if it works, you just trust that it's actually there. So, for instance, routers actually end up working for us, okay? Things like firewalls are also a big part. So, Vaughn, for me to provision a firewall in a regular network, right? So, if we go back in the series, almost towards the beginning of our series together on the cloud fundamentals, I mentioned that the idea of actually getting hardware to be, to get installed in the network, it can take time, right? So, Vaughn, you realize, hey, I want to actually implement this type of firewall, let's say a Cisco ASA. Well, at that point, if Vaughn actually says, here's what we need to configure it, well, Vaughn may not be in charge of actually buying the equipment, which means Vaughn has to now submit an order, probably internally, to then get put on the list, to then take a look at that piece of equipment, explain why it's the piece of equipment that we want and why it's actually the one that you need and everything. And Vaughn, that might be, let's say, several days later, maybe even weeks or maybe even months before you get that piece of equipment back. But because of the way that cloud services work, according to the definition that we've been looking at throughout the entire series, the idea of being able to deploy it on demand is the key. So, Vaughn, if all of a sudden you realize for your cloud environment, you go, I need to actually implement a firewall, you simply go and you select that firewall and you say, hey, I want to start paying for the usage of this for this networking service, and it actually works for you. Okay. So it just simply is there. The other things that we also can do with this, especially in the cloud, is something like we call server load balancing as well. Okay. So when we start to actually think about the idea of how much traffic that we run, Vaughn can build a very simple cloud environment for what she wants to do. Let's say it's a website, just as an example, and she runs it off of a single web server. Well, let's say that Vaughn's particular web server, a product that she's pushing up, it goes viral. And now Vaughn's getting, let's say, 100,000 hits a minute. Vaughn's little tiny, web server that's sitting out there because she's on the free tier of AWS, she's getting pegged like crazy. And now she has to actually expand that service out a little bit more. Well, she might actually have to bring up multiple instances of those servers, but she would also need to, of course, connect to a load balancer that allows her to distribute that load as well. Well, she can do that. It doesn't require Vaughn to go out and purchase that hardware equipment and put it in there. She just simply tells the cloud provider by picking the, the services that are available, deploy it, and then make sure that she actually configures it right and it actually deploys and does what we need to. Okay. The other one that's actually a really big product that we're going to spend a little bit of time on here as well is the idea of what we call WAN accelerators here. Okay. WAN accelerators essentially act like a proxy or a cache for us that allows us to actually connect very quickly or make it seem like we're connecting quickly when we need to. Okay. So all those are actually examples of different services that are actually available for us that we can actually go through. Okay. Now, Vaughn, here's just kind of a question, and I'm expecting you not to be able to answer this. Okay. So, Vaughn, if we talk about the idea of a router inside of the cloud, or even if I go to a switch inside the cloud, where would these switches and routers reside? Okay. Where would they actually be? And we know that they're in the cloud, but where are they actually in the cloud?
Is it in the FI layer?
Well, for us, it'd be the connection to it, but it's really we don't know where it is. Okay.
Oh,
so
okay.
So we
yeah.
really don't know where it is. It could
It's that
be
ethereal thing going on
Yeah.
again. It's like it's
Yeah.
just floating out there.
right. So
somewhere.
we're right here in Florida. Okay. But the server I may be connecting in might be in Northern Virginia. Okay. It might be over in Redmond. It might be in San Jose. It might be all the way across the world for all that we know. Okay. But we just don't know where these devices actually are located. Okay. So in that sense, when we start to actually do something like that, Vaughn, how is it that, let's say that my particular cloud service that I am as a tenant, that the majority of what I'm actually in is somewhere in one region, but you might actually have some of these other services that are located differently as well. Okay. So let's say that even within a data center, they're not directly connected just to my network. These devices, even virtualized devices, are actually put somewhere, and we don't know exactly where that goes. So that means that behind everything even we're now talking about virtualized routers and virtualized firewalls and load balancers and all that stuff that we're talking about here, we now need to think about how do we get traffic from Vaughn's web server. Let's say it's on, on server 16 in rack B, okay, somewhere, just as an example. What if the actual router software, the services are actually running over on rack C on, the A server, okay, something like that. Well, how do I ensure that the data that needs to go out and needs to go through the firewall actually does that? It literally goes over to the services that I need it to, okay? So in that instance, you have to begin to understand that when we start to do that in the conventional way, Vaughn, in terms of topologies and diagrams, it's fairly easy, okay? We set up a web server, we connect it to a switch, the switch then connects to the router, and then we say it goes out to the network somewhere or internet, okay? So that's easy because we can see that linear path even if I were to draw that out. But in cloud services, it's hard to actually draw out that linear path anymore, even though logically you still see it that way in your mind, and that's what you want to be able to do. So what really happens, though, is that now means that when we start dealing with cloud services, we have to depend on different ways that what we can actually do so that we can use the services is do something that we call traffic steering, okay? Traffic steering essentially is saying, take the traffic that's leaving here and direct it to, well, one of these services that I've been talking about, okay? Because, Vaughn, I don't know, like I said, they're not actually deploying a single one for me. They're actually saying this device actually does reside somewhere that we're virtualizing, so it can be done that way, okay? So those are some of the things that you want to be able to do. So, Vaughn, let's talk about a few methods that you and I actually, or at least one method that you and I know on how we actually get traffic to go where we need to, okay? So, Vaughn, let's take a look at a diagram that I've set up, and this is more conventional, okay? This particular diagram right here, okay, allows me to be able, I'm trying to make sure that we can see it. We'll do it here in a moment, okay? So let's just take a look at the diagram, and then I'll take a look at the configuration here in a moment. I'll even drag that over for a moment so that we can get more of it when I zoom out, okay? So Vaughn, notice that there's VLAN 10 and VLAN 20 over on the left-hand side of the screen is connected to a switch, and I have a single link that's connected out to a router, and I even see the ports that it's connected to, okay? Now, Vaughn, for me to go from VLAN 10 to VLAN 20, in the world of networking, I cannot directly just send data from VLAN 10 to VLAN 20, even though they reside on the same switch together. I can't directly do so, okay? So they could actually be, and two ports could be side by side on each other, one in VLAN 10 and one in VLAN 20, and I can't directly send a message that way without there being an intervening device like a router, okay? A router is what allows me to connect between the two different subnets, and notice I have the subnets actually listed here, between the two different subnets that are actually available. And when I do that, the traffic steering mechanism that I'm using here, Vaughn, is actually creating a trunk link, okay? So on the switch, you can see where I've actually configured this particular interface as a trunk. And now when I do that, it's saying allow multiple VLANs to be able to go out across this link here. And then on the router side of the configuration, I'm going to zoom in this way, okay? On the router side of the configuration, Vaughn, I've actually configured a router interface into sub-interfaces. So you see the 0.10 and then the 0.20. I'm taking that FA0/0 and subdividing it and saying treat it as if it's multiple interfaces at this point. I've put on IP addresses for each of the network. I've also encapsulated them in .1Q for VLAN tagging and assigned the actual numbers here. What I'm relying on, Vaughn, here in terms of traffic steering is that what that's going to do in the routing table is going to create two different routes for me. So that when traffic from VLAN 10 goes to VLAN 20, it will send it into the actual router, and it will see that, hey, VLAN 20 is actually over here, but because it's actually something that the switch boundary cannot cross, it will have to send it to a layer 3 device. A layer 3 device will look up in the router the route to 10.0.20.0, and when it does, it will send it out this sub interface here, which goes right back out this interface and then gets me to VLAN 20. So Vaughn, notice that what I did there is by using the configuration on the switch and the router, I steered the traffic to go where I need it to go, okay? That is by far kind of the most simple way, or one of the simplest examples that we can use of traffic steering when we start doing so, okay? So Vaughn, even though that does that, at least starts to send traffic in the right direction, that is probably not the only way to do so. Okay, so here's another one that we can take a look at instead. And this one is a little bit more technically challenging at this point, but it is also there too. Now, for those of you that go on towards your CCNP route, you'll be taking a look at policy-based routing a little bit more. But let's take this, for instance, Vaughn. Notice that on the top of my diagram, okay, we have the connection out to the internet, and I have a router right there, okay? And notice that I also have another router beneath that that directly connects me to the LAN. But Vaughn, in the environment that I've also put in here, to the right of those two routers, I have them connected to a firewall. So Vaughn, I know if I go from the bottom of my diagram here on LAN 10.1.0.0, and I say I need to go out to the internet, well, Vaughn, the direct path out to the internet at this point is really going from here all the way through there. And I used to be able to actually change the color to this thing. Let me see if I still can. Oops. Not anymore. Okay, so there we go. Let me change that. Now I'll try and do it. There we go. Okay. So I was like, I used to be able to do so. So that's the actual easiest path to go to. But Vaughn, what if I wanted to change that? Okay. I don't want it to go directly that way. I want it instead to go through the firewall. Okay. Well, if I want it to go through the firewall, that means I have to consider on the router itself, and for us, we can set up what we call policy-based routing, okay? With the idea of the policy-based routing, I just set up an example, okay, that we have. I tell it, here's the actual route to the firewall itself. So let's say on this particular router here, okay, because the default way of doing it, it actually will just follow the lowest metric on the routing protocol the way that's set up. But if I can actually set this up to where on this router over here, I can say, go ahead and learn the 172.16 network, which is over here, going to the firewall. I can tell it also it's going to permit the 110 network to any address that it wants to. But when I do so, I've set up this condition here based on a policy. So the route map called net10 says to permit, well, 10, which is what it says, okay? So that's the first thing it says. It says to go ahead and allow this traffic, but only if it matches address 110, which is this access list. So what this is saying is as the router it comes in, as data comes in here, it says, take a look at this, find this route, but here's the way you conditionally allow the traffic to go through. If it matches this entire network over here, this access list, okay, permit it, okay? When it permits it, it's saying send it out of FA 0/1, which I think I should have actually said, oh, I think I get that one backward. That's my fault. That one should be 1/0. I typed it in backwards. That is totally my fault. I was like, why is that going the opposite way? So tell it to actually send it out. So as traffic comes up here, if I can find the pointer again. So once it hits here, it hits that particular route map, and it takes a look and goes, hey, that matches the access list. And it says to send it out this direction, and now we are going through the firewall, okay? So once again, another example of being able to use policy-based routing to help me to steer traffic towards the directions that I need it to go, okay? And that's actually a very important one because it gives us way big granularity, okay? That means I can actually set this, if I chose to make it very specific. Now, on this one, we do have where it's an extended access list, and I can tell because access list 110 or anything over 100 is pretty much going to be an extended access list. It gives me the actual protocol as well as the source and destination, which is to any, and it actually says, all right, use this condition to help you to match and say what interface that traffic is supposed to be sent out instead. So that's what it does. Even though, Vaughn, by default, remember, okay, it should just say what? Just go ahead and use. I'm trying not to delete. It's going to delete everything. All right. So even, never mind. There we go. Finally. I didn't know I did it in two parts. Okay. So even though it's normally going to go straight across and straight up this way, instead it says send it up here and then go over to the right-hand side to be able to do so. Traffic steering, again, is kind of the way. In virtualized services, we always think about the idea of how to make this happen. So I'm showing you essentially the old ways that we would normally use to make this work. Okay. And the reason why is you understand both of these, right? You begin to understand the way that we actually did traffic steering before, but now we have one more that we need to take a look at, which is closer to the way that we actually do traffic steering in the cloud as well. Okay. Now, Vaughn, the last method that we're talking about here is a little bit strange. Okay. This particular method of traffic steering is called WCCP. Okay. And you see where I have this listed as WCCP server, WCCP client, and also the protocol that's listed here. Okay. So when we do this, this is WCCP. Okay. It stands for Web Cache Communication Protocol. And essentially, it is a reverse proxy, is what it also does for us. Okay. Now, when we start to take a look at this aspect of how this ends up working for us, okay, when we choose to go from my machine, which is the 10.1.0.124 machine, and I'm trying to go out to itpro.tv, okay, so our business right here, our website, notice here's the source machine. When I send that up to the router, what is the normal default behavior? The normal default behavior is that the router says, let me look it up in the routing table. Oh, you're out there on the internet somewhere, and let's send it through to itpro.tv. Well, if I have WCCP protocol turned on, and that's usually going to be at this router right here in the center that I'm talking about, okay? So if that is actually turned on, it will do something a little bit differently here, okay? Well, with WCCP, there's also this client, which we call a proxy. And what the server and the client does in between here, okay, that is actually, it uses this protocol on UDP 2048, okay. I would make sure I know that protocol, okay. UDP 2048 is going to be for WCCP to make that work. Now, once we send that data up and we tell it that I really want to connect to itpro.tv, the next step that it does instead of sending it to itpro.tv, the server will take that message and it will now establish a GRE tunnel, okay, a general routing encapsulation tunnel. And that's because it doesn't want to add in any additional headers into what the client is going to actually receive. It wants to actually allow the client to actually be able to say, hey, we're going to send this through, and the other side is not going to see it as being manipulated as well. When it responds back, it actually is going to come back as if it came directly from IT Pro TV as well, okay? So the GRE tunnel gets established and we connect to that proxy server. And when we tell that proxy server, okay, that what 10.1.0.124 wants to do, okay, it sends from itself, a message, okay, to, oh, that should have been one arrow going this way. Now, I don't know why I put two different arrowheads. But I did, so that's my fault. Let me change that one. Okay. It sends it from itself at 10.1.0.200, and it sends it all the way out to IT Pro TV, goes all the way back across. And so when it actually sends it, it's sending directly to the proxy server itself, and it goes through the GRE tunnel again. And now what happens is when the actual WCC client, what ends up happening is it sends a copy of that. Notice the source, though, is not from the client address, but it's from itpro.tv. It sends it all the way back as well, okay? So that's what ends up going on, too. So now that particular traffic is also going to send all the way back across here, but it's going to also look like it came from itpro.tv, okay? So that's the way that that works. Those three are, again, physical ways that we've done it in the past, okay? They're fairly slow by comparison of what we're about to talk about, okay? But you at least want to make sure you understand the idea of traffic steering first. There are different methods in the cloud, but if you don't have this understanding, yes, I can actually make data move or go where I want it to go, okay? Instead of just relying on the default protocols that are out there, well, then you're not going to understand the nature of the virtualized networking at all, okay? So, Vaughn, those particular three ways of doing things are actually going to become very important because next, when we start to talk about what we need to, in the cloud, we start using something that we call vPath is what we start to use here, which is the virtual services data path or virtual services data path. Make sure I'm telling you correctly, to be able to actually make the same thing happen, but without needing to rely on the idea of VLAN manipulation, policy-based routing, or even the WCC proxy as well. Okay, essentially, VPath is going to replace all three of those methods in the cloud for us to make sure that it works. Now, Vaughn, before we go on to do all that, okay, like everything else, I tend to talk way too long, and that means that we are just about close to out of time. So instead of trying to cram in a whole bunch in the last 3 or 4 minutes here, okay, what I want to do is just slow it down a little bit and go into a part 2 to ensure that we can cover everything that we need to so that we understand the idea of virtualized networking better instead of me just trying to force it all onto you at one point. So, Vaughn, this is a great place for us to end this episode.
All right. Well, you are steering us away from that nice review. It's always good to go over everything, know what it was like in the old ways, and now we're going to move on to the new ways. So us twinsies over here are going to go ahead and sign off for IT Pro TV. I've been your host, Vaughn Smith.
And I'm Ronnie Wong.
We'll see you soon.
Thank you for watching IT Pro TV.